Maya 2 has many new enhancements targeted specifically towards the games and interactive content creator. New workflow improvements and a solid feature set provide a highly efficient environment to create cutting-edge content for real-time applications. Using Maya 2's user interface, we are able to interact with our model in a fluid and comfortable way. With the use of manipulators and the ability to work in a hardware-shaded view, we can cut down our modeling time considerably. Now that we have the tower's shape, we can see that it is still faceted. Maya's Smooth Normals functionality can take care of this by smoothing out the normal across those edges. This does not increase the poly count. It simply averages the normals over the edges of the model. New in Maya 2 is drag and drop shader assignment. Using this feature allows us to simply drag a shader onto the object we want to texture. With the shader assigned, we can now apply a cylindrical projection to the tower. Notice how the projection fits the bounding box of selection. This makes it very easy to drop any projection onto a selected object or selected faces and have the projection translate and scale itself into position. But for this tower, we want the brick texture to be stretched across each individual polygon. For this, we can use the new Advertise UVs command. With one click, the texture is perfectly mapped to each polygon. Maya 2 also gives us the ability to copy and paste UVs and shader information from one polygon onto another. Here we can copy the roof texture and its UVs to our new roof. So once we have set the UVs for one polygon, we don't have to do the same work over and over again. This gives us a tremendous gain in productivity. We also have new enhancements to the Texture View window. The Texture View window can show us the texture that is applied to a mesh as a background image. This makes it easier for us to map complex textures onto objects by allowing us to position UVs on the texture itself. We also have manipulators in the Texture View which are readily accessible through the common Translate, Rotate, and Scale hotkeys. We can easily change the mapping of polygons by using these hotkeys and their associated manipulators. And of course, we can copy our changes from one polygon onto other polygons. We can now go ahead and create the arms of the tower by using a nonlinear deformer. This new feature in Maya 2 allows us to manipulate geometry in ways that would have been difficult, if not impossible, before. By applying a simple bend deformer to this duplicated version of the tower, we can easily bend it to the desired shape. Then we can delete the deformer, and the object is baked into the final shape. Once the arms are in place, the tower is complete. Using Maya 2's brush-based interface, we can paint vertex colors onto our model. First, we change our view mode to render our scene using the vertex colors. Notice how the tower becomes black. This is because there are no vertex colors on the model. We can easily apply colors to the model by using our familiar Painterly user interface. We can bring up our color chooser and simply paint vertex colors onto the model. Notice how the green color we painted on the bottom of the tower blends with the algae texture. Using this functionality, we are able to add subtle details to the model's look without adding more textures. In Maya version 2, we've re-engineered our character skidding technology to provide both a simpler workflow and a highly realistic result. The process of binding a character's skin to its underlying skeleton is uncomplicated and intuitive. We first select the skin geometry and follow by selecting the skeleton. Then choose the Smooth Skin command for binding. This new smooth skin binding technique allows geometry to be shared between multiple bones, creating a very effective look. Notice in the minion's neck how the skin behaves exactly as one would expect as we rotate it back and forth. If we take a look at the wing, you can see how the skin between the fingers appears to stretch and fold as we open and close those joints. Even difficult areas to skin, such as shoulders and torsos, behave correctly. When we encounter situations where edits to skin deformation need to be made, we can utilize Maya's integrated brush-based editing technology to quickly modify the weighting of the skin. By simply selecting the geometry we wish to work, the weighting of each joint's contribution can be adjusted with a series of additive or subtractive brush strokes. Blending and flooding brushes are available as well to assure smooth transitions. While painting, the weights for the rest of the joints are automatically normalized. When specific numeric adjustments are required, Maya's new component editor also allows the adjustment of individual skin weighting values. IPR is a radical new productivity tool that has been added to the rendering workflow in Maya 2. By selecting an object in the IPR window, all the attributes of its associated shader are presented for real-time editing. This editability extends beyond simple color changes into all aspects of texture control. The result of complex shader linking operations, like driving a bump map's depth and distribution with a procedural texture such as this fractal, can be quickly adjusted and optimized. The same instant feedback applies to lighting. Select any pixel and then turn on the lights that are illuminating it for edit. Change a spotlight's cone angle and see the resulting area of illumination. Similarly, changes to penumbra angle yield instant feedback on the softening of the hard edge of the spotlight's beam. Finally, by increasing the light's drop-off while increasing its intensity, we achieve the desired combination of beam brightness, gradient into shadow, and area of coverage. Another new aspect of Maya 2's rendering workflow is Hypershade. Hypershade is designed to allow simple construction, visualization, and editing of rendering shade trees. In Hypershade, shader connections can be made through a straightforward point-and-click interface. Shader balls provide visual feedback on the results of shader tree edits. Interactive pan and zoom in the Hypershade window allows close inspection of shader appearance. Shaders from Hypershade can be selected, dragged, and dropped onto scene objects either within the IPR window or directly in the 3D view. In complex scenes, quick select sets can be easily created and accessed for such material assignment. Here we've dragged the staff shader and the outer ring shader onto those elements of the Jester's wand. Now simply clicking on those objects in the IPR window brings up the attribute editor of their assigned shader, and interactive adjustments can proceed. First, we'll adjust the bump parameters to give the outer ring a look of beaten gold. Next, we'll bring up Hypershade again and drag a new shader onto the orb at the center of the Jester's wand. With Maya 2, IPR also provides interactive editing of 2D special effects like light glows and motion blur. For our adjustment, we'll use IPR to edit the intensity of a 2D effect known as a shader glow. With shaders, lights, and even 2D effects fully tuned, our scene is ready to submit to a final batch render. Maya Complete now has the ability to easily integrate special effects into any 3D scene via a library of predefined, customizable clip effects. The flow effect allows users to control the flow of particle animation along a path curve. A volume around the path is represented by a wireframe cage that can be manipulated to add variation to the flow. Here, various sections of the flow volume have been scaled to create a larger area in the path for the flow of particles that will be added to this logo element. Each cross-section of the flow can also be repositioned along the length of the volume to vary the timing of the animation of the flow. Additional effects can be achieved by adding a new emitter to each of the existing particles. These new emitters can have their own display and behavioral attributes. Here, the original particles have been hidden, and the new emitted particles are then connected to a predefined emitter, allowing for the reuse of desired effects. The color and transparency of these new particles, shown here, have been animated to create a pixie dust effect. This flexible method for creating particle effects by combining various emitters and previously defined particle attributes allows animators to quickly and easily iterate on the designed look and timing of the intended effect. The display of the particles can be customized to achieve any number of desired effects. A list of preset display options is accessed in this example to achieve a streaking sparkle effect. Here the particles are traveling through the volume based on the random sizing and timing of the flow for their animation. The behavior of the animation can be further modified by animating the way in which the particles are emitted. By keyframing the emission rate of the particles during the first few frames of the sequence, as in this example, a short cloudburst of sparks has been created. Maya Complete's clip effects also contain a variety of predefined smoke effects. After creating the effect, applied to the smokestack seen here, the animator has access to a series of manipulators that allow for interactive control of the direction for the smoke to emit. The manipulator can easily be changed to gain control of the spread of the smoke's emission as well. The particles can also be scaled independent of the emitter. In this example, the smoke has been scaled smaller, and the smokestack has been replaced with a steam grate, achieving an entirely different look while using the same clip effect. Timing curves for the animation of the clip effect particles can be accessed through Maya's graph editor. By simply changing the animation curve on the particle motion, behavioral attributes that may have been desired will remain unaffected, leaving complete control of the timing to the discretion of the artistic director or animator. In this example, the timing curve on the steam has been modified to create a backdraft effect. Maya Cloth can be used to easily create realistic clothing and other dynamic cloth animation by stitching together a series of panels into a garment, much in the same way that real clothing is constructed. Panels are created from a collection of border curves that outline a section of the garment being created. Here, a series of panels have been created to make a chainmail shirt for this creature. The original panel is shown here being converted into a garment object, which creates a polygon mesh connecting the border curves for each panel. Adjacent panels can be automatically stitched together by creating seams along the shared edges of the panels. The resolution of the resulting polygon mesh can be changed at any time. Here, the resolution of the shirt is increased, which will add more detail to the folds and creases in the garment when the simulation is calculated. Creating a seam between a panel in the front of the shirt and the back will automatically stretch the connecting mesh around the shoulder of the creature. Each of the other seams are shown here being stitched together in a series of seaming operations, making a shell surrounding the entire character. The volume described by this shell will be used to shrink fit the clothing to the character's body when the simulation is executed. Fitting the cloth to the body of the character is achieved by specifying certain surfaces of the character's body as collision objects, allowing the cloth solver to determine where the clothing will drape and fold across the surface. Here, a painted chainmail texture is applied to the mesh. The texture will stretch and tile properly along the edges of the seams, creating an accurate representation of the pattern when the garment shrinks in the simulation. The tightness of the shirt is further controlled by changing the scale value used by the cloth solver. The solver then calculates the volume of the garment, as well as the effects of gravity and the contours of the collision surfaces to create a realistic article of clothing. The shape of the fitted shirt can then be saved as the initial state for the garment, allowing the character to animate and have the garment fit properly throughout the duration of the animation. Paint Effects is an innovative new technology from Alias Wavefront that allows users to interactively paint special effects and highly intricate detail within the 3D context of Maya. By making an object paintable, rendered effects can be painted directly on the surface of a 3D model. The Paint Effects tool gives the user access to an extensive library of predefined effects brushes. Here, a blue glowing neon brush has been selected to add electrical effects to the orb in the Jester's Quest logo. The glow and transparency of the brushes are rendered in real time as the paint stroke is created, and each stroke in this example is treated as a curve on the surface of the orb, which will render accurately from any view. Painting can be done either in the context of the 3D scene or on a 2D canvas. The brush library contains many predefined mixed media brushes, including felt tip markers, airbrushes, charcoals, pens, and pencils. Each brush uses accurate transparency to layer the color and texture on the canvas. A collection of natural media brushes allows for the creation of complex textured paint strokes like oil paint, plant leaves, or geometrics, and can be painted on a fully tileable canvas, valuable for creating seamless, repeatable 2D textures. A watercolor brush is used here to achieve a subtle painterly effect in the image, and a watercolor smear brush is added to create a natural drip effect. Any of the brushes from the preset library can be customized and stored as an item on the tool shelf. Here, a fully 3D natural media brush has been modified to create the vine on the Jester's Quest logo. Realistic shadows of the leaves are rendered in real time as the stroke is drawn. Because the strokes have been drawn directly on the surface of the geometry, they can be viewed accurately from any angle and will calculate proper shadows and occlusion. Any of the attributes on the brush can be animated over time to achieve effects such as growth or wind turbulence. Increased realism and complexity can be easily achieved by influencing any of the Paint Effects strokes with Maya's powerful dynamics and deformer capabilities. In addition to the numerous animated effects that Paint Effects brushes can achieve, they can also be used to easily add geometric details to objects or characters, which would otherwise be very tedious to model individually. In this example, small horn-like features have been quickly added to the surface of this creature's head. All of the watercolor brushes that were introduced on the 2D canvas can also be applied to three-dimensional surfaces. Here, a watercolor smear brush has been used to create a drip effect on the skin of the creature's face. Like any of the effects brushes, this drip effect could also be animated to create a stunning melt effect. These effects, or any of the hundreds of effects created with Maya's Paint Effects technology, will revolutionize the way that image creation is approached. Paint Effects technology integrates a paint paradigm directly into Maya's visual effects production process, and allows for fast throughput and design iteration of complex visuals and environments, all completely integrated with the powerful modeling, animation, and rendering capabilities of Maya Complete.